Chapter 12 is a mini unit of graphing and exponentials. So this first video is just going to be about families of functions and then how we take certain graphs and have domain restrictions on them, which basically just means the x values are getting restricted. So first of all, remember that, and a lot of this is going to be review in the beginning. So we have a slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. And then point-slope form is y minus y1 equals m times x minus x1. Okay, where once again m is the slope and then x1, y1 is a point on the graph. So our parent function is going to be y equals x. And remember that the parent function is just basically the most generic function to graph. Nothing's different about it besides it starts at 0, 0 and has a slope of 1. So 0, 0 and then has a slope of 1. Okay. And that is our parent graph. Any shift off of that, then changes what the graph looks like. So we take a look at example 2. Okay, remember that this is the y-intercept, and the y-intercept is where we start the graph on the y-axis, so 0, negative 6. And then since this is a positive slope, it's rise over run, so up 3 over 1. Okay. And then we would use a straight edge, of course, to graph it. Okay. And then example number 3, you could technically move the 1 back over, so to make this point slope form, so y minus 1 equals 1/3 x plus 4. So therefore our point is negative 4, 1. And then the slope is 1 over 3, and it's a positive slope, so we're going to rise to the right. So up 1 over 3, up 1 over 3. Okay. Remember that negative slopes, which would be example 1, falls to the right. So it looks like this. Okay. All right, quadratics. Okay. This is the unit we just got done with, so hopefully this is fresh in your mind. Vertex form, standard form, and factored form. Okay, so the graph on the right is just the parent graph again. So the parent graph starts at 0, 0. And then remember it has the 1A, 3A, or you can plot points, like make an XY table. So 1, 2, 3. And remember that we graph using symmetry. Okay. All right, I don't want to spend too much time on these graphs since these were the ones we just tested on. The one I will quickly take a look at is number 3. So number 3 is actually factored form. So the factors are x equals 0 and x equals negative 2. Okay. You also could have multiplied this out and then found the vertex from there, doing opposite b over 2a. Okay. But by multiplying it out, it does leave us room to possibly make another error. So remember that we take the average, or basically in the middle, so that's negative 1, and then plug negative 1 back in to find the y value, which will also be negative 1. So my vertex is negative 1, negative 1, and then a is 1 still, so up 1, up 3, and if you make an XY table, then use symmetry. All right, let's go to the next page. So we have a square root function. If I plug in -9, this isn't possible. If I plug in -4, not possible. -1, not possible. The square root of 0 is 0. And then 1, 2, and 3. So parent graph off to the right. So we have 0, 0, 1, 1, 4. Sorry, I accidentally flipped back. 9, 3. Okay, and there's our graph. So just like quadratics, we have a standard form for square root function. So y equals a x minus h plus k, where hk is the starting point, just like a vertex. Okay. And it tells us how much to go up and down. And we always move to the right first now, 1, 3. Or you can make an XY table and plot the points. So this first one, the starting point is going to be 0, -4. Okay. And then for right now in our class, we're always going to go to the right. So then you can plug in 1, and that's going to be -3. And then you can plug in 4, because that would be the next square root, perfect square root. So that would be 4, -2. And then you could plug in 9, and that will give me -1. Okay. The reason why I picked these numbers is because they were perfect squares, so I knew that when I plugged them in, I would not get a decimal underneath. Okay. Let's go ahead and take a look at the next one. So first of all, my starting point is going to be 5, 0. Okay. Make an XY table again. If I plug in 6, that'll give me a perfect square. So 6, 1. If I plug in 9, that would get me a perfect square, and then I'd be off the graph, so that's fine. Okay. And then the last example, my starting point would be 0, 0. And notice that the a value is different, so that's just going to make our graph taller. So xy, if I plug in 1, that's going to be 3. If I plug in 4, that's going to be 6. And then we would be off the, well, actually we could still probably do 9. Yep, we can do 9 and 9. Okay, so notice it just made our graph taller. Okay. All right, and then the last function we need to talk about is an absolute value function. Remember, v for absolute value. Okay. So 0, 0 is the parent function, and then the slope, just make sure you make a v, and it's 1 and 1 on each side. So 3, 2, 1, 0, 1, 2, 3, and that's why we make a v. Okay, let's just do number 2. So number 2, the starting point is going to be -1, 0. Remember that the same thing that we used for quadratics and square roots, we can apply to absolute value, where hk is the vertex, and that's how we got -1, 0. And then my slope is 2, and because this is a v, it does make a constant rate, we're going to go ahead and graph it like slope. Just make sure you make a v. So v for absolute value. All right, so that was all the review part. The next page is where we're really going to get into the heart of what this entire unit is about. So it says graph each function on the given domain. So basically we're going to graph the function, but we're only going to graph part of it for whatever the domain tells us to do. So this one says when x is greater than or equal to 0. So I'm only going to graph from when x is greater than or equals 0 to the right. Okay, so the line y equals 5 is a horizontal line. Okay, and it's, remember that less than or equal to or greater than equal to is a closed circle, and then less than or greater than, I know I flipped those the way I was saying them, but that's going to be an open circle. Okay. All right, so we have a greater than or equal to, so closed circle, and I only want for when x is greater than or equal to 0. So look down at the x-axis and decide which way is greater than or equal to 0. That would be to the right. So I'm only going to graph my line to the right. Okay. Now, when they are horizontal lines, they're pretty quick to graph. They get a little bit more complicated as we move along our functions. So, for example, this one does have a slope of 1/4, so it's going to make some type of diagonal line. And I just want the line for when x is greater than -4. So one way to do this is actually go ahead and plug in -4 into the function. And that gives me -1. So this graph is going to start at -4, -1. And I know the big question that often gets asked is, well, why are we starting at there when x can't equal -4? Because what about -3.9? What about -3.5? We have to take those in consideration. So we're going to start at -4, -1, but have an open circle at that point. That's a really bad circle. Okay, and then my slope is 1/4, so I'm going to go up 1 to the right 4. Okay, now this one you technically could have started at 0, 0 and graphed it, but I think it's good to start at what we call these endpoints of the pieces. And what you do is you just plug in, regardless if it's an open circle or a closed circle, you just plug it in. Okay. All right, let's go ahead and take a look at example 3. So make sure you guys are paying attention to what type of function you're working with. So we are working with a quadratic here, which means I need to have a U-shaped graph. Okay, and then the important part is when x is less than 3. So go ahead and put in 3 into the function to figure out where our starting point is going to be. So 3 squared minus 2, and that's going to give me 7. So my starting point is 3, 7 with an open circle at that point. Why is it open? Because it's less than 3, it's not greater than 3. Now, since it's less than 3, I only want everything in this direction to the left, because that's less than 3. So what I'm going to do is I'm going to go ahead and graph this. So 0, -2. I'm going to go up 1 over 1, up 3, up 5. And notice then that I meet that closed circle, or that open circle. And then just graph by symmetry. Okay. Now you have to be careful on this one. Make sure that you include the arrow over here, because this side is not stopping because it's everything less than 3. I was just stopping here because I wasn't allowed to go past that. Okay. All right, so what I want you to do is you're going to pause the video in just a moment and try number 4. And then when you get back, when you're done, hit play and check your answer. All right, so here's what we should have gotten for our answer. So first of all, plug in -1 into the function, and you get 7 back out. So that was my starting point, -1, 7. And then this slope is a -2, so that means I need to fall to the right, or in other words, go up and to the left. So I went up 2 over 1, up 2 over 1 to the left. Okay. All right, and then the last page is just more of practice. Okay, So we're going to go ahead and just do 2 more problems and then we'll be done for this video because the bottom problems are actually on tomorrow's notes or the next day notes. So notice that the only difference here is now there's 2 restrictions on the domain. I only want the space in between. So I go to -10, 4, and that's going to be a closed circle. And then I go to 2, 4, and that's going to be a closed circle. And I just want the space in between. Okay. And then same thing here. And then for the last one, notice we have an absolute value function. Okay, so I'm going to plug in these numbers to get my ordered pairs for my endpoints. So -2, 2 and 8, 8. So -2, 2 and 8, 8. And that's supposed to be an open circle, sorry. So -2, 2. And then 8, 8. Okay. And then this should actually be a closed circle. And then notice that this is the parent function. So that's going to start at 0, 0. And you're just going to go up 1 over 1. Sorry, I just hit the over button again. To finish off your graph, and notice that we just graphed a section. Okay, and then 12.2 notes, we'll be practicing more of piecewise functions and how we graph multiple ones at the same time. Thanks for watching.